Welcome to Lecture 8 Embedded C Data Types for 8051 with example using Keil, Part 3. Already we have discussed the 4 data types: unsigned integer, signed integer, unsigned character, signed character. One more 3 data types are there. It is related to 8051: S bit, bit, and SFR. This is the RAM memory location of 8051. We know the RAM memory location of 8051 is 128 bytes of RAM. It will start from 00 to 7 up. In that RAM, the few memory addresses having bit addressable. Here you see 20 at the memory location to 2F memory location, we having the bit addressable. But 00 to 1F and 30 to 7F, there is no bit addressable. Suppose you want to read or write the particular bit, 00 is the location of that particular bit. If you want to make this 00 bit as 1 or 0 with the help of this bit, for example, it is a 50, it is a bit. If you want to read or write with 1 or 0 with the help of this bit, we can perform. Next is this memory organization is related to the special function register. It is also located inside the 8051 microcontroller. It will start from 80 to FF. This is the SFR memory organization of 8051. Here the few register having bit addressable and few register not having the bit addressable. In this diagram itself they clearly mention what are the memory location having the bit addressable and what are the memory locations not having the bit addressable. Suppose you want to write or read the particular bit. Suppose this is a 94, the bit. If you want to make 1 or 0 with the help of S bit. In SFR, if you want to access or read or write the particular bit with the help of S bit, we can perform. The third data type, it is a SFR, special function register. If you want to access or read or write the data from the SFR, not only the bit addressable, the entire address. Suppose you want to access, for example, here you see the TH0, TH1. Suppose you want to access this entire bit with the help of SFR, it is possible. As well as bit addressable also possible, not bit addressable memory location also possible with the help of SFR. Here I take a microcontroller. I want to make pin P1.0 and P1.1. I make it off. Okay, for that I have to write a program. As include regx51h. It is a header file because whatever the memory SFR, in SFR, whatever the registers available over here, we want to add over in the program. You have to be use this as include regx51h. Here we are using the P1.0, P1.1. It is related to SFR register. That's why I have used this header file. Already I told the P1 is located over in the where in SFR register. So I want to access the single bit, that is 90, 91. This is P1.0, this is P1.1. Suppose I want to access this bit, I want to access this bit. Usually, already we discussed port 2, port 3, port 1. You switch on the microcontroller, switch on the power supply. The microcontroller give the 5 volt across the second port, third port and first port except port 0. You can go through the previous lecture. You can able to understand why you are not getting port 0 and why you are getting a port 2, port 3, port 1 you are getting plus 5 volt. Suppose I want to make this P1.0, P1.1, make it this LED off. So P1.0, because I am using only one bit in the port 1, so that's why I using the keyword or the data type S bit. LED equal to P1 cap 0. So P1 cap 0 now assigned with LED. Why? For our comfort, rather than using P1 cap P1 cap 0, simply I can use LED. Likewise, S bit LED 1 is equal to P1 cap 1. So P1 cap 0 is assigned with LED, this LED, that is a D1. P1 cap 1, that is the LED 1, that is the LED, this LED. So void main is a while of 1, that is an infinite loop. Whatever the statements you written inside the while loop, it is going to be execute infinite times. So while of 1, I will make LED equal to 0. LED is equal to 0 means I make 1 cap 0. This is the first pin. Whatever the LED I connected, so I make it this LED off. LED 1 equal to 0. P1 cap 1 is assigned to LED 1. So whatever the LED I connected with P1 cap 1, I make it to 0. That is a program. Now I go into the Keil program. Okay, I copy due to the time constraint. I hope already you know how to open the new project, create a project name, as well as how to create a target, and under the target how to write the program and save it with the .c extension. Now I'm going to be just save it already with the file name test5.c already saved. Now I'm going to be compiling, build and rebuild. Now I'm going for the debug operation. I want to see my outputs in port 1. Okay, why I use this keyword sbit, I want to access this p1.0 and p1.1 with the help of sbit. Now I want to make these two bits is going to be off. Usually p1 it is high. I want make that two bits p1.0 1.1 as 0. So I going for stepwise operation. The first LED becomes 0, that is p1.0 becomes 0. The next it is 0. Okay, and it is an infinite loop. Okay, always p1.0 and 1.1 is 0. They come to the second program. Here, write a C program to get the status of bit 1.0, save it in the somewhere location in the RAM and send it to port P2.7. So here S bit, so P1 cap 0, I get the status of the bit. If it is a 1 or 0, okay, that assign that P1 cap 0 to in bit. This is a file, this is the name I assign this pin. S bit out bit is equal to P2 cap 7. So this pin is assigned with the name out bit. You must carefully see this is a bit. So if you using the bit where had to be accessed in the RAM location 002 FF, anywhere you can save. Suppose you are writing in the assembly level programming, you can specify the which location you want to save, that whatever the data available in the P1.1, sorry 1.0, which location you want to store, that location we can specify in the assembly level programming. But here, suppose whatever the data you are writing on 1.0, it is randomly, it can choose some location on the RAM. So bit MEM bit, that is a name I assign over here instead of bit MEM bit. Okay, this is a keyword of data type with the name MEM bit. Here I am not mention any the bit, which bit I am going to be, what is that, save this the status of P1.0. But in case of assembly level programming, it possible. Now void main, while of 1 it is an infinite loop. Here in bit I have to be check the status of P1.0. If it is 0 or 1, continuously check the status. Whatever the status I am getting in P1.0, that has to be transferred to MEM bit. So the microcontroller 8051 microcontroller, it randomly select the one bit from the RAM location, RAM bit addressable location. After that, you have to be transfer this, the bit, whatever the bit stored in that RAM bit addressable, that has to be moved to outbit. Outbit here I mentioned as P2 cap 7. With the same file name, I just going to be replaced with this new program. Just save. Now I going to be compile, no error, build and rebuild. Here I am using the two bits. One is P1 cap 0 and port 2, that is 2.7. So I have to be check the status of P1.0, that is moved to MEM bit, that is the bit addressable from the RAM. After that I move it to the P2.7, this bit. Suppose I want to access, I want to see the RAM address. So D colon, why D? The RAM is the data memory. D colon 0x20. Why I have mentioned 20? Because of the bit address will start from here 20 to 2F. We don't know which location that bit is going to be stored. For example, in the 0th position, if it is the bit is located over here 1, so the rest of all the bits are 0, so 0 1, the 20th memory location having the value of 0 1. If it is a 0, it is 0 0. Now I am going to be demonstrate this one. So now I have to be check the status. So now it should check this is a 1, that is 1 is moved to the 20th location, here 0 1, not 20th location, it is a bit, this bit 0th bit, 0th bit only, that 1 is written over here in the 20th location. The rest of all the bits are 0, this is 1. So you convert this binary number into hexadecimal, you get 0 1, that is specified over here. Now if I make this P1 cap 0 as 0, 1 cap 0 as 0 has to be run this program. So in the D you will get a 0, that 0 is transferred to port 2. Okay, that is the use of this S bit to access the single bit in the SFR bit addressable. This bit keyword or data type is used to bit addressable in the RAM location from 00 to 7H. The third, then the last data type of 8051, it is SFR. Write and C program to toggle all the bits of port 0 continuously with some delay. Use the SFR keyword to declare the some delay. Okay, with the help of this for loop, we are unable to set or fix the time delay. With the help of timers already available in the 8051, with the help of that we can able to fix the time delay. For example, 1 millisecond, 2 millisecond, 25 millisecond. If you want, there is some calculation is there. With the help of that we can able to fix the time delay. But with the help of for loop, it's not possible. Just come over here. Here I am not use the header file because I use that SFR as a keyword. Here I am using P0. I am going to be access the entire port of P0. The location, the memory location is 0x80. Just you look over here, the P0. I am going to be access this entire memory location, that is P0, it is a register. Okay, 80 to 87, it is a 8-bit register. The memory location is 80 memory location. In SFR, this all the registers are related to this SFR. If you are using SFR directly, no need to use as include reg51.h. Rather than using that header file, I simply use the keyword SFR. With that, I access this the entire port. P0 is equal to 0x80. That is the syntax. SFR P0 port 0. The memory location, the address of that P0 is 0x80. Here, void ms delay, this is user defined function. You have to be declare that user defined function always above the main function. I use this user defined function after this main program. Here void ms delay, because in the program I asked to generate some delay between, that is toggling the inputs, P0, this is a while of one, it is infinite loop. P0, just look it over here, can able to understand. P0, I am sending 55. It just you converted over here in the binary 0, 1, 0, 1, 0, 1, 0, 1. After having a some delay, here I am running this delay function. Once it will run this, execute this line, it directly goes over here. In I return some for loop. This loop has to be run for some millisecond, that creates some delay. After that, in the P0, I am sending AAH in binary 10101010. So this P1 P0.0 pin is 1, after some millisecond becomes 0. Likewise, I toggling all the bits of P0 with some delay. After that, again I will toggle it. Just come to the program again, can able to understand this is a delay function of this program. Now I am going to be run with the help of Keil. You can able to understand very clearly. This is a delay function. This is also a part of the function. Why here I return the user defined function. I want to create the delay. I want to toggling, so definitely we are in need of delay. The same program, due to time constraint, either replace program. I am going for there is a one error in the ms delay. Here I am not used the semicolon, that's why it's showing error, 0 errors. Okay, now everything is fine. Now I go for debug mode. I want to check the outputs. Here I am using only port 0, so port 1, port 2 not required. I directly go for peripherals, IO port P0. Now I am going to be run. Here you see this is toggling AA55. In port 0, in across the pin you are not getting the output, because here already explained you, the port 0 in the across you will not get any output until you will not connect the external pull-up register with 5 volt. You must connect external pull-up register. You can drive this the output of these pins. But in case of port 2, port 3, port 1, it's not required. But port 0, you are in need of external pull-up register. But in P0 register, this data is available. 55 and AA is available. But in the pin, the physical pin of 8051, you will not get the output, because the inside the configuration is there is open RAM. Suppose you want to make this pins also get a output, you must connect the external pull-up with 5 volt. The port 0 register, this is a port 0 register. In this port 0 register, you will get the values, that is 55 with some delay AA. It is available in the P0 register, but not available in the the pins, physical pins of 8051. Thank you.